Okay, so this system here is in equilibrium, right, where you've got this mass of 15 kilograms, all right, held by these two ropes at these angles here. But we need to remember that it's all focused on x, isn't it? This point x here. So and we need to see the forces resolved at x. That's what I'm keen on there, right? Because the forces also the focus on x, don't they? That's where it is, right? And that's where everything is balanced. Okay, so we've got our weight here, haven't we? The 15 kilograms times gravity, so 15g. And then we've got the tensions in these strings. Now you can call these tensions anything. You know, you could call that tension yx if you wanted to. You know, you could have called it that, tyx. And this tension in this string, xz. Okay, it's up to you. It doesn't matter what notation you use. I'm going to call it just T1, T2. That will do. Okay, that makes sense to me. But what we need is the angles, right? So important we have the angles here at x. And we don't have them, don't we? We have the angles up here. But what you can do, right, I think this helps here. If I draw a parallel line here, just keep going from that line upwards, that weight there. What I hope you notice is we've got like a Z angle, okay? So actually this angle here is actually the same as that angle there. So you've got a Z angle, okay, because that line is parallel to it all. So that's going to be 60, isn't it? Okay, and then similarly then, this angle here, you've got another Z angle, haven't you? So that's going to be 45. Okay, degrees. So that's good. And when you've got that then there, it's up to you how you go about that then. You could work out what this angle is if you wanted to, which would be with 30. Okay, so we could do that if you want to. It really is your choice. Okay, it doesn't matter. So when I've got my forces here, I can appreciate then that maybe this angle here is 30 degrees. Okay, and it's your choice. Or you could keep that as 60. And then the angle here will also be 45 degrees. Okay, because remember that we've got a right angle here. If we go across that, so if that's 60, that's going to be 30, and of course that's going to be the same as that, 45 degrees. So when I get a force diagram then, remember the force diagram, we go like that, yeah? We look at sort of the vertical direction, the horizontal direction. Now we've got 15g going down, straightforward. Now tension has a horizontal component and a vertical component, doesn't it? So if I look at the horizontal, it's with the angles, that'll be cos, so it'll be T2 cos 30, and then up here then it'll be T2, well it'll be the sine then, won't it? Okay, because we'll be looking at this side here, which is opposite that, so it'll be T2 sine 30. And then when we look at the tension one here, well with the side here, okay, the adjacent here, that'll be the cos there, so that'll be T1 cos 45. As I said, if you're not sure about this sort of thing, you need to go back to the coplanar forces, okay, those videos to see how to resolve the angles properly. But don't forget then you've got the T1 cos 45, and then of course the T1, it'll be sine 45 up there. Okay, now it's in equilibrium, okay, so we could say that, and we'll state that, so we'll say, look, in equilibrium. So therefore, when we resolve horizontally, we can say, look, T1 cos 45 equals to T2 cos 30. Okay, and I think there's going to be a bit of substitution involved here. Okay, so perhaps what I'll do now, because I've got this, before I resolve vertically, I can say, therefore, T1 equals to T2 cos 30 divided by cos 45, yeah? So just take that cos 45 over. Now when I resolve them vertically, I've got these two here, T1 sine 45 plus T2 sine 30 will equal then the 15g. Okay, so upwards equals, the up forces equal the down force. But then I hope you can see that actually then, if I call this 1 and this 2, I can sub 1 into 2. Okay, so I can put that in here. So T1 is actually this, isn't it? So I can say, look, T2 cos 30 over cos 45. So I'm literally replacing this, right? I'm replacing the T1 with this here from what T1 is equal to from equation 1. But then you've got to times it by the sine 45 plus T2 sine 30 equals 15g. Now I know that sine 45 and cos 45 are the same, but you know, so they cancel each other out. You can check on your calculator if you want, and you've just got this then. T2 cos 30 plus T2 sine 30. Okay, so if you notice here, because cos 30 is root 3 over 2, and sine 30 is a half. Okay, so you've got something plus something. You've got something T2 plus something T2. it's important to notice. This is like when you've got something T2 plus something T2, we can add them together, can't we? Like what I could do is factorize out the T2 and do that, yeah? You can do that if you want. So then to get the T2, I've just got to take that over and divide. So 15 times 9.8, divide them by all of that. And I get my T2 out. So it looks a lot of work, but actually, if you're just consistent in your approach, you won't have too many problems. Just appreciate how to eliminate one of the tensions. So let's try and get this sorted out here. So I can do all this one go on my calculator. Okay, and that's what the sort of thing I get. If you can see that there, that's what I get. And just type all that in one go, and I get out the answer to be 107.6 newtons. Okay, it's 107.6, and then obviously then you need to then sub that in then to get T1. All right. So if I sub it into that, I get T1. So T1 then will equal 107.6 cos 30 all over cos 45. Okay, so that's all I gotta sub in. I've subbed it in there, so put my T2 in. So basically what I could do is I could press fraction ants cos 30, okay, all over cos 45. Make sure we're in degree mode, of course, right? I am, thank goodness, I've done that right. And then I get 131.8 newtons, okay.